First, I was going to say thanks very much to Dave, the Sioux there at Springfield, Missouri, and also Jason for setting this up so I can give this presentation, and also to John. Again, my name's Dave Hotz. I'm the science officer from Morristown, Tennessee. I want to present the Storm Monitor Analysis Program, but before I do, I really want to recognize some people that really contributed a lot to this program, especially Jason. Jason there at Springfield, Missouri. This program would not be possible at all if it wasn't for Jason's hard work, so I definitely want to recognize him. He's done a lot of work with this program. But we're going to go forward. Great, if you want to go to the next slide, go ahead.
I'm with you now.
That's all right.
And there we go.
Okay. Thanks, Greg. The purpose of the Storm Monitor program, it really kind of goes back to some best practices during surface assessments. And one of the themes that always comes up was understanding and having a good situational awareness of your near storm environment. And this program that we're going to introduce during this presentation is a tool that local offices could use on your AWIPS to help you monitor situational awareness across your forecast area. Go ahead there, Greg. What we're going to talk about now is pretty much kind of the program input. There's really two types of input. We have a wind input and also a kind of a thermodynamic input into the program. For the wind input, it really contributes to the shear and helicity values that this program produces. And the type of input for the shear and helicity values, we use the surface observations such as ASOSs and AWOS sites. And also you can use kind of an and/or. You can use the RAP winds. You can also use your VAD wind profile from your radar, use winds from there. And also you can use significant level winds. Personally, here in Morristown, we really don't use the SDL because we don't have a RAVS on site here, but you can use that information. So again, you have the surface data as well as the winds aloft from the RAP or VWP. Now for the thermodynamic input, such as like CAPE and DCAPE, you can use, it's kind of an or. You can use the RAP data, or you can use the LAPS data. So it's kind of, you decide which data you really want to use for the thermodynamic information. And as soon as new input comes in, as soon as you get the new METARs, the VWPs, new update to your RAP, the monitor is continuously updated with the new data. Go ahead there, Greg.
Okay, Dave, this is John. I'm back.
Hey, John. John, if you want to go ahead and go to the next slide, go ahead.
Okay, there you go.
Thanks. Okay, under the display menu button, you will get what they call attributes table, and that's what you see there in the middle. And that's all the different types of values or parameters you can look at on the program. Right now, there's right around 28 parameters that we have for this program. And what you'll be able to do, you can take off and on the different parameters. So if you want just certain parameters you want to look at for this event, you can put them on and you can leave some of them off. So it's very adaptive to whatever you want to look at for that scenario. Go ahead there, John. Okay, the first series of attributes that we have is the shear helicity values. You can turn on the 0 to 1 kilometer, 0 to 3, 0 to 6 kilometer shear. You also have helicity values you can look at, VRN shear. Another thing you can look at as well is your buoyancy and stability values. So you can look at the LCL heights. You can look at capes, ML capes, so kind of the hail capes and D capes. There's a lot of different values you can look for buoyancy and stability. The next set of values are your composite parameters. And what we do is we compute the composite parameters given the helicity and buoyancy values that we get. And some of the composite parameters that we have is EHI. You also have a significant tornado parameter, Craven and Brooks, significant severe, Derecho composite. So those are different parameters we can use, composite parameters. Some of the miscellaneous parameters we have, we do look at, it's called a 50 dBz heights, and what that is, it looks at Donovan and Jungbluff's technique that they developed, the regression analysis they developed, and it takes the freezing heights and lets you know what values of heights of 50 dBz core heights would be for severe hail. Another thing we look at is precipitable water values and the TE difference. What that is, that's the theta E difference between the surface and the minimum level theta E difference. So it kind of gives you a much better chance of seeing potential microburst potential during the event. John, go ahead and go to the next slide. Thank you, John. Okay, now what we're going to do is kind of talk about more of the monitor display and let this thing kind of get it figured up. Okay, the first thing you see on the monitor is the left-hand side. And the left-hand side, what that is all the different stations that you have set up for your monitor. And really for our area here in Morristown, and I'm sure Jason's kind of the same way for Springfield, Missouri, but what we do, we set up all of our different ASOS and all of our AWOS sites within our forecast area, and then we also grab the different observation sites, kind of the north, west, and south of us. So we have a kind of a feel for what's kind of coming in. But those are the different stations on the left. Go ahead there, John. And then the top part of all the different parameters. One thing you will notice is that everything is color-coded. So it's color-coded to let you kind of, it's kind of like the avian FPS. If it gets a certain color like purple, that lets you know these values are really getting pretty extreme values. So it kind of highlights the potential of those different parameters. The next thing we have is the station tabs, and we'll kind of talk more about the station tabs a little bit here, but the station tabs allows you to look at a timeline graph of all those different parameters, but we'll look at that a little bit more here in a little bit. Okay, another aspect that you're able to do on the monitor is that you're able to click on the different parameters on top, and it allows you to rank the parameter. So like in this case here, you have ML Cape, you have it ranked from highest to lowest. So you can see what stations and what areas of your forecast area or your warning area that you're really beginning to see a higher potential for that parameter. And here's just another example. If you click on a significant severe, again, you can rank it from highest to lowest. Go ahead there, John. Okay, now the timeline graph parameters, how that works is this. From the timeline menu button, you grab whatever you want to look at. So in this case, we're going to look at the Craven and Brooks significant severe. So go ahead and go to the next slide, John. And what we're going to do is that you grab one of the stations on the top, one of the top tabs. In this case, this is Greenville, Tennessee. And we're looking at the timeline graph for the Craven Brooks significant severe weather parameter. And the line that you see that has the arrow, that is the current time. So everything back shows you the timeline graph of this parameter for the last 24 hours. So we always kind of found that kind of interesting. For one is if you ever do some research later on, you can use this timeline graph. Another thing too, just kind of give you a feel for how this parameter has evolved through the event. Go ahead there, John. Okay, the next part of this program is if you go from the main monitor, if you click on one of the stations, for example, this is CHA, which represents Chattanooga. For the next slide there, John. What that does, it gives you an interactive hodograph. So every station that you have in your monitor, you can click up on interactive hodograph, and this interactive hodograph has, again, your current surface observation for that location, and also you can use RAP winds, VWP winds, also SGL winds, and it gives you a hodograph for that location. And the neat thing about this hodograph is it's interactive. So all the blue dots for the different levels is you can move them if you want to. I think the greatest feature actually is the yellow dot. And what that is the calculated storm motion. So let's just say if you had a storm that latched onto a boundary and decided to go more southeast in the main flow, you can move the storm motion to reflect that more of a southeast or kind of right-moving flow of that storm. And what you'll do is you can move the yellow button and move it to that motion. And then the helicity values and shear values that you see on the top right will also interactively change as well. So you can see how that right-moving storm has changed the helicity and shear values. Go ahead there, John. Go ahead and go to the next one there if you want to, John. Okay, this slide just represents that when you get this program, you do get kind of the set cam thresholds for the different parameters. But as used in Office, if you want to modify what you want to be as a threshold for those different parameters and how they're color-coded on your monitor, you can change that the way that you want it. And another thing at the very bottom, you see the precipitable water values thresholds on the bottom. You can set the precipitable water thresholds depending on Matt Bunker's climatology for your area. Okay, and this kind of goes to what this talks about. You know, again, we monitor precipitable water on the monitor, and if you wouldn't mind going to the next, there you go. What you can do, you can set it up so it monitors what Matt Bunker has set up on his climatology, and we kind of really found that very useful in keeping the forecasters very situation aware that this is an environment that's getting to extreme level. So we kind of found this to be kind of pretty useful for using Matt's climatology. Thank you, John. Another thing that you're able to do is in Office, again, you can change the way that the program is utilizing the data. For example, in the current monitor setup, we're using the RAP winds for the monitor. So it's currently using surface observations and the RAP winds for determining the shear and helicity values on the monitor. But if you wanted to, you can turn on the significant winds or VWP winds, depending on what you want for those locations. Now, the analysis data, what that allows you to do is to look at, for the buoyancy and stability values, do you want to use the LAPS data or do you want to use the RAP data? So you can change that for every station, or you can make every station the same. So it kind of gives you the flexibility to set up the way that you want it. Go ahead there, John. What I want to do now is give you two operational case examples that we utilized the monitor over about the last year or so. Go ahead there, John. Okay, this is during the April 27th tornado outbreak that we had here in eastern Tennessee. During that time frame, we ended up getting about 50 to 55 tornadoes within about 24 hours time frame. But this is during the event is right around 2Z on the 28th. But you can tell, you know, everything just really sticks out real well, that the helicity values, the shear values were very, very high. Again, you can look at LCL heights. Another thing like you can do as well is look at the significant tornado parameter. So all these really parameters, the nice thing about it, they really just kind of stick out at you as a forecaster, and you can see how these things are evolving during the event. Go ahead there, John. Okay, this next is the timeline graph for the significant tornado parameter. This is also during the April 27th event, and this is for Chattanooga, Tennessee. And Chattanooga, Tennessee area, they had several tornadoes that went right across, pretty close to the airport. And what I did, I kind of highlighted the different times they had the tornadoes. And the neat thing about it, you can see in this timeline graph is how the STP parameter, you know, jumps up pretty much right at time, right at the time that they have these different tornadoes. So I always kind of thought that was kind of interesting for the timeline graph. Okay, this is the same hodograph, but this is the hodograph at Chattanooga, pretty much during the time when they had one of their tornadoes. And you can, this obviously kind of sticks right out to you that this is a very much a tornado type hodograph for the Chattanooga area. Okay, this is the next event. This is a Derecho event we had back in last summer. It was kind of a mini derecho. But what I want to kind of point here is that, again, you can look, the ML capes really stick out at you. The other parameters that we see as well is D cape. D cape also stuck out. The theta E difference also kind of sticks out to the forecasters, that this is a big potential of seeing kind of a high wind event. And the last parameter we stick out as well is the, this is the derecho composite parameter. And then also you have a significant severe parameter. It was very high that day as well. Okay, this kind of final thoughts to kind of wrap things up. When Jason and I wrote this program, this is really, I think, a very great program for situational awareness, but we also want to stress to our forecasters that this is just one tool to use as a toolbox. Definitely, I always tell our forecasters here to use SPC Mesoanalysis page. It's a great diagnostic tool. AWIPS with its LAPS data, MSAS data. So there's a lot of other tools you can use besides the program. But again, this program is a great, I think we feel like it's a great tool to use for situational awareness. Another thing we want to do, we wanted to acknowledge some different people allow us to use some of their code. Jim Raymer allows us to use the test grid/wrapper program. This is a program that Jason was using a lot to grab the kind of the instability and buoyancy parameters off the wrap and the LAPS models. And also we want to recognize Matt Bunkers. Matt allowed me to use his shear helicity calculations and also for his PW climatology. And last, see if there's any questions, but we want to let you know that the Storm Monitor program, we are planning on migrating over to AWIPS 2. I was talking with Jason here just not too long, a couple days ago. It is going to be a process to get that done, but that is something we plan on working on. So if you have any questions about the program, if you're interested, feel free to call myself or Jason. We'll be happy to work with you. All right, well, thank you very much there, John.
Well, thank you, Dave. We sure appreciate it. And also, Jason, are you on the line too?
I am.
Okay, I just want to say thank you. I think you both did some great work here. And any questions from any of the Sues or anybody else in the audience?
Got one from Jackson. The parameters when you set up your thresholds and all, is that saved and stored per user, the forecaster, or is that as an office as a whole?
Okay, that's a good question. What we have it set up is that when you first get it into your office, it'll be set up as just an office. But as the different forecasters utilize it, what it'll do, it will save a copy of the attributes parameters list within their home directory. So the next time they get in there, it'll have just a list of what they want to look at. So it will get it set up so every user can look at whatever they want to look at. So that pretty much means that if you're on workstation 2 and you have another forecaster workstation 4, you guys can look at different things. Does that answer your question?
Yes, excellent. Thank you.
Uh-huh.
Yeah, question from Chicago here.
Yeah.
Noticed in your timeline graphics the frequency of update would change a little bit there. For instance, that STP timeline you showed from the April 27th, 11th, 2011 event. Was wondering what dictated that frequency of update. Was that be dependent on the data that is going in there, the vertical wind profile, for instance, updating more frequently at times?
A lot of times the reason why you have a really disparity between, how many times it's updated has to do, let's just say for Chicago, excuse me, if you have Chicago and you have a series of special METARs that come in, well, every time one of those specials come in, it's going to recalculate those values. So, sometimes you might have maybe somehow the one is going to update like once or twice or maybe twice an hour, but then if you might have a couple hours, it might update a whole bunch just because you have specials coming in.
So that's totally dependent on the surface observation.
Exactly. So anytime you have any type of data, either surface observations or your VWP updates or the RAP is updated, your monitor and also the plot that you see is going to be updated.
All right, great. Yeah, I can see that more frequent update being a real benefit of this tool over, say, a mesoanalysis and hourly update, something that would update more regularly, such as observation site, or if you have your lab set to update every half hour. So
Exactly.
Appreciate it. Great presentation, Dave.
Sure, thank you. Any other questions out there?
Is there somewhere we can download this program right now?
Okay, I know for the LAD is now closed up. If you want, I should have said this, but if you want the latest update to the program, feel free to email me and or Jason, and we'll get you the latest. We'll get you the latest updated software, and also we'll send you the latest documentation on the program.
Got a question from Des Moines. Thanks for your presentation. On the Hodograph, we saw the storm motion there was the 30R75. Are you using bunkers, or is that?
Okay, what you can do for the storm motion, you can change that. You can it defaults. I think it kind of defaults to one that you said, but you can change. On the monitor, you can change the default storm motion on the fly if you want to. But like in this case here, when it comes to the Hodograph, you can change the storm motion within the Hodograph. So if you want to take the yellow dot and move it around and change it, you can do that. I hope I answered your question.
Yeah, so could you, for the default, can you have that default to the bunkers motion, or you have to move the dot to get that?
Initially, I'll default to the bunkers motion, but from there, you can change it on the Hodograph.
Okay, thank you.
Oh, you're welcome.
Dave, this is John. I have a quick question for you. I put this back up here, and I noticed that sometimes there's two data points at a given time, or three in some instances. Is that, what was typically that? Is that just because a METAR came in at the same time as a new VWP, or is...
Yeah, that's pretty much what's going on, John, is that you just have kind of overlapping data coming exactly at the same time. So it kind of calculates two values for that same time frame. That's one of the features of the program that I wish we can kind of change a little bit, but that's what's happening.
Well, no, that's good. I mean, you can know if your data is coming in too.
Yeah.
Does it become obvious if suddenly you lose some data on AWIPS, or it's not, somehow there's a failure somewhere? Is it just that the data just goes away and it just, or does, I didn't know if there was something after a certain period of time, like some of the,
maybe an FPS?
Yeah, these just kind of zero out or something like that. I know you have last update, but I didn't know if, if it got really long, like we're talking about hour and a half. I didn't know if those change color or something like that.
I don't think the current version of this monitor does that, but that's something we could probably add. Maybe for the last update, if it doesn't change, if you don't get the latest update, maybe it changes color on you, just kind of let you know. That's a good point. Any other questions out there? I want to say, if you do have any questions later, feel free to ask Jason, myself. One thing about this program, and I was talking to Jason a couple of days ago, we really kind of wrote this program as almost like a prototype, something that we thought would be kind of neat to have in local offices. Like I told Jason, I am not a professional programmer, and I can only go so far. So we would like to try to develop this a lot more than what it really is, and hopefully our vision down the road is that maybe some guy that has much more programmability than me can take this over and really run with it. But maybe it's a national program. But we definitely like to kind of show the possibility with this monitor. Thank you, John.
No, thank you, Dave, and also Jason for all your work with this. We sure appreciate it.